To the first problem out of a set of problems given at a local examination for high school students. The first of these reads as follows. In a tennis tournament, there are 2N participants. In the first round of the tournament, each participant plays just once, so there are N games, each occupying a pair of players. Show that the pairings for the first round can be arranged in exactly 1 times 3 times ... 2n minus 1 different ways. Another way of conveniently writing this would be of the form 2n minus 1, and then all of that quantity, double factorial. So try this out for yourself, and then in a second we'll do the proof. Alright, fantastic. So let's go through the proof. And we'll see that clearly this product has exactly n terms, since we have 2n minus 1 down to 1 is 2n terms, but because we're taking step size of 2, they're exactly n terms. This makes sense since they're n games. So to see how this works, let's draw out an arbitrary set of n players, in this case, of 2n players, in this case n equals 3. And we see that the way we can do arrangements of this tournament are in the following way. Let's choose an arbitrary player at first. They can play exactly one other person, of which there are 2n minus 1. So the first term is 2n minus 1. They have 2n minus 1 options. Next we'll choose the next player. Well, if we look about, we see that we've eliminated one player and their partner. Therefore, whatever player we choose next, arbitrarily, has exactly 2n minus 3 options, since we've eliminated 2 players. And in this selection, we'll eliminate another 2 players. And continue this process until we choose our last player, of which there's only one possible partner for them. So this is times 1. This will generate every single possible arrangement. And note, we do not need to multiply by any kind of rearrangements, in the sense that, what if we had chosen a different player to begin with? Our choice was totally arbitrary. There was no specification on the actual individual players themselves. Therefore, if we had chosen this one or this one, it doesn't really matter, because we can do the entire process up to a rearrangement of the player, or relabeling of the players. But we don't even care about the labels since they're arbitrary players. With that, since we have 2n minus 1 all the way down to 1, we see that there are exactly this many options for games, since if we had chosen instead of this player, we had 2n minus 1 choices, and we could have proceeded in a similar way. With that, we have the total number of games, and thank you for watching.